You're welcome to my channel. I want to be speaking today on hash function algorithm simplified. Now, hash function algorithm is a type of encryption. In one of my videos, I talked about the three types of encryption we have a private key cryptography, uh, we have a public key cryptography, then we have a hash function algorithm. Now, it is a third type of encryption I want to be speaking specifically upon today, which is hash function algorithm. Now, hash function algorithm basically is used uh, to ensure integrity objective. I talked about the objectives of encryption. There are four. We have confidentiality. When the authorized people should be able to read uh, an encrypted information. Authentication, we should be able to verify the identity of the sender. Then we have non-repudiation. Anybody that initiates a transaction should not be able to deny that he initiated the transaction. Then the fourth is integrity. We want to be sure that the message we are receiving has not been altered. Okay, instructions. For example, in a war situation whereby orders are being given from headquarters to the operational commanders, it's very important that you are able to confirm that the information you are getting is, even though it's coming from the headquarters, has not been altered. Okay, because of the implication. Okay, so that is why the hash function algorithm was developed, and there are so many algorithms there. For example, SHA 1, secure hash algorithm 1, secure hash algorithm 2, and so on. Message digest. Okay, so there are many types of the hash function algorithm outside there, and the idea is this. Okay, if I have a message, I should be able to find what we call a digital summary, of the message. Now, that digital summary of the message is what is called hash. All right, it's also called digest. So let's assume I have something like this. Aki goes to school. Just be simplified. Aki goes to school. Okay, so I can find uh, a hash. So I will use maybe SHA1, SHA2, MD2, message address 2, whatever algorithm that is applicable. I can hash this message. So let's assume, just being hypothetical now, let's assume the hash of this message is this. Okay, so how many characters do we have here? One, two, three, four, five, six, seven. Seven characters. So let's assume this is a hash of Akin goes to school. I want to send you the message, Akin goes to school. So I get the message across to you, Akin goes to school. Then I will also now send this hash digest to you. That this is a digital summary of the message I have sent to you. So when you get my message at the other side, so you get Aki goes to school also. Then you, as a receiver, now you getting the message. You have the hash function also. So you too, you are going to recompute the hash. So let's assume luckily the hash, since the message has not been altered, you will get exactly what I sent to you when you perform the hash function operation. So you will know automatically a message I sent to you has not been altered. But let's now assume that somehow the message was intercepted on the way. So instead of going Akin goes to school, somebody changed the message to Akin goes to the market. Yeah. So somebody went to misinform you and change the message to Akin goes to the market. So when you get a message, since you have the original hash that I sent to you, then you too will perform the hash function operation, then you are going to get something else. That's what it means. So perhaps you're going to get something like this. 1, 2, 3. It's going to be of the same length. Okay, 7. Fixed length. Hash functions always have fixed length. 1, 2, 3, 4, 5, 6, 7. Good. So this is what you got as the digital summary of the message. So you compare this, which I sent to you, with this, which you got. They are not the same. So automatically, you know that the message that you received was not the message I sent. So that is how simple hash function algorithm is. The other thing I wanted to know that it is not reversible. Okay, I convert this, I can go to school to this. I cannot get this back from this. You normally encrypt, you have encryption, decryption, but you can't decrypt with hash function. So the idea is not really to encrypt. The idea is for you to be able to know if the message has been altered. And this simple principle is actually used in password management. It has an application in password management. The idea is that you could have a password. So let's assume my password is uh, Terry underscore 35. Let me put this. So this is a strong password. So we have capital letter, small letter, special character, then alphanumeric. This is a good one. So this is my password. Now, if I key in, let's assume I want to log into uh, a banking application and enhancing application, the system should not ideally store my password like this, because if you store my password like this, then a hacker can hack the password file and is able to have access to my password. And that means the whole system is compromised. Now, in a good password management system, what the system does is that it can use SHA-1, SHA-2, whatever hashing algorithm to hash my password. So my password being stored could be stored like something like this. 1, 2, 3, 4, 5, 6. So let me make it 7 characters, just like we have. Okay. So this is what the system will store as my password. So even if you have the password file, all right, this is what you're going to get. You're only going to get the hash of my password. You're going to get hash of my password. Okay, and you can reverse. You can reverse from this hash to the original password. So that is the security that hashing passwords provides. So you can reverse. So this is what you're going to have. So every time let's assume you have already created the password. So every time you try to log in with the password, what the system actually does is that whatever you type, it hashes it and compare the hash of the password you just typed with the stored hash. So if they are the same, it gives you access. If they are not the same, it tells you that either the user ID or password is incorrect. The good system will not tell you that the password is incorrect, because I've seen systems that will tell you the password is wrong, which is not good security. A good error message should not tell you whether it's your ID or your password that is incorrect. It just tell you either, so that it will make the job of anybody trying to hack your password more difficult. So this is one good application of the hash function algorithm. I've said it before, it is used to determine integrity of messages, and it is also used in password management to ensure the security of the password. So you don't store password just as people type it because of the possibility that the file can be compromised. So you store the message as a hashes. You store the password as hashes to improve the security of the password management system. My name is Akinola Yakundi, and once again, thank you for watching this video. I hope you will subscribe to my channel so that you can have access to more videos. Thank you.